Good morning. How are you? Today we are going to start our new lesson about special right triangles, lesson 18.3. This will be part 1 and prepared by me, Ms. Salma Ahmed. What do you know about the side length and the trigonometric ratio in special right triangles? So by the end of these slides, we are going to find the relation between the side length and the trigonometric ratios in a special right triangles. What are special right triangles? We are going to have a 45, 45, 90 degree triangle, and we are going to have 30, 60, 90 degree triangle. The ideas that we will talk about are, number 1, we are going to have explain 1, applying relationships in special right triangles. Number 2, we are going to have a trigonometric ratios of a special right triangles. Let's have the first type, which is 45, 45, 90 degrees triangle. Here we have an isosceles triangle, so the two legs are the same. In 45, 45, 90 degrees triangle, the hypotenuse is root 2 times as long as each leg. So here we have the 45 degree triangle. The two legs are x and x. The hypotenuse should be x root 2. This is the rule that we are going to follow in the following slides. So how can we deduce it? By using the Pythagorean theorem, as it is a right triangle, we can deduce the upper relation. Leg squared plus leg squared give me the hypotenuse squared. So the legs are x, so I'm going to substitute x squared plus x squared give me hypotenuse squared. So it will be 2x squared give me hypotenuse squared. As I need to get one hypotenuse, so I'm going to take a square root both sides. So it will be hypotenuse equals square root 2x squared, which is give me x root 2. Here we have the same answer of the hypotenuse is the same in the rule that he gave it to me. Example, if I have this triangle which is 45, so I have one leg which is 5, so the other should be 5. Let's follow the rule that we took it before or from the previous slide, that the hypotenuse should be x root 2. So it will be 5 root 2 exactly. Another example, if I have a triangle with leg 8, so the other will be 8. So the hypotenuse will be x root 2, which is 8 root 2. Another one, if I have the leg 4 and the other leg should be 4, then the hypotenuse will be exactly 4 root 2. Now I have more examples, but he's giving me the hypotenuse, which is 10. Here I need to get the leg from the hypotenuse. So the leg here, we can find it by the hypotenuse divided 2 times root 2. So 10 divided 2 give me 5 times root 2. So the answer will be 5 root 2, and the leg of the other leg will be 5 root 2 also. More examples on this. If I have a hypotenuse which is 12, so I need to get the leg which is 12 divided 2 times root 2. So I'm going to get the hypotenuse divided 2 give me 6 times root 2, it gives me 6 root 2. So the other leg should be 6 root 2. The last one here, if I have a hypotenuse which is 14, so it will be 14 divided 2, which is 7 times root 2. It gives me 7 root 2, and the other leg should be 7 root 2 also. So you can use this relationship to find side length in these or in this special type of right triangle. Let's have the example which is in your books, page 955. Here we have this triangle which is 45. I need to find the unknown length which is AC and BC. Here we have the hypotenuse which is 10. So I can get it from the previous that I can get the leg by taking the hypotenuse divided 2 times root 2, which is give me 5 root 2. Here we are going to follow the steps and we are going to find out that it will give me the same answer or not. Solution. Find AC and BC. As it is a 45-degree triangle, so we can say that the hypotenuse is x root 2. So I can say that the given hypotenuse 10 equal x root 2. I can find x, so x equals 10 over root 2. We can't leave any radicals in the denominator, so I have to get rid of it. So x equal 10 over root 2 times the same radical that I have in the denominator. I'm going to multiply it up and down. So it will be 10 over root 2 times root 2 over root 2. It gives me 10 times root 2 give me 10 root 2, and root 2 times root 2 give me 2. So after simplifying 10 over 2, it gives me 5, and root 2 stay as it is. So here's the same answer that we get it from the previous slide. It gives me 5 root 2 also, so the two legs are AC and BC equal 5 root 2. So here, the two legs that we found it. Your turn, page 956. Here I have the same triangle, which is 45, but the given one is one leg from the two legs that I have, not the hypotenuse. So the leg is PR, which is 2 root 6. Now I'm going to find QR and QP. So I need to find the other leg, which is QR, and I need to find the hypotenuse, which is QP. So it's very easy and helpful when you are drawing the triangle that have the same rule, or the rule that we studied from a while. So here the triangle, which is the legs are x and x, so the hypotenuse should be x root 2. As it is a 45-degree triangle, PR equal QR equal x equal 2 root 6. So here we have a QR, it's the same leg or equal the same leg that he is giving to me, PR. So it will be 2 root 6. Now I need to find the hypotenuse, which is QP. As QP equal x root 2 from the previous slides or from the rule. So the x, we get it from the previous step, which is 2 root 6 times root 2 that I have. By using your calculator, you will find it's 4 root 3. So here we have QP is 4 root 3. This is the hypotenuse for this triangle. Example. Find the trigonometric ratios of the 45 angles. So do you remember the trigonometric ratios? Oh yes, we have it from the previous one, which is sine, cosine, and tan. Here we have our triangle, which have the hypotenuse BC equals 10. So I need to find sine, cosine, and tan for this triangle. Now we are going to have the two legs. Find the two legs wherever with any method that you want. So if I have the hypotenuse, which is 10, the leg is 10 divided 2, the hypotenuse divided 2 times root 2. So it will be 10 divided 2 give me 5 times root 2, it will give me 5 root 2. The other leg should be 5 root 2 also. Now we are going to start by sine B equal cosine C equal AC over BC. Why sine B equals cosine C? Because we took it before that sine B is equal cosine the complementary angle. So both B and C are 45, so I'm going to substitute it. Sine 45 equal cosine 45 equal AC over BC, which is opposite over hypotenuse. So it will be 5 root 2 over 10. After simplifying, it will give me 5 divided 10 give me half root 2, which is root 2 over 2. Now I'm going to get the tan 45. Tan is sine 45 over cosine 45. Here we have both angles are 45, so sine and cosine are equal root 2 over 2. So I'm going to divide root 2 over 2, divided root 2 over 2, it gives me 1. So here we have tan 45 equals 1. This leads us for the following table, which is a very important table actually. It's angle 45. If I need to find sine and cosine, so they have the same answer, they are equal root 2 over 2, and the tan here is 1. So if I have the triangle which is legs are x and x, we have substituted it by 1 and 1, so the hypotenuse will be 1 root 2. Since the lengths of the side opposite of 45 angles are congruent, they are both 1. The length of the hypotenuse is root 2 times as long as each leg. So it will be 1 root 2, or we can say it root 2. We can say it root 2. So we can deduce the following table, which is very important, and you have to study it very well, that sine 45, it gives me root 2 over 2. By sine, it's opposite over hypotenuse, which is 1 over root 2. As it is a radical in the denominator, I have to get rid of it. So it will be times root 2 over 2 over root 2. So 1 times root 2 give me root 2 up, and root 2 times root 2 in the denominator give me 2. Here we have the sine and the cosine will be the same, and the tan will be the division of sine and cosine, and it gives me 1. Thank you very much. I hope you understand what we said, and please watch the next one. It's the second part for this lesson. If you have any question, just contact me. Thank you very much.